Okay, in this screencast we're going to solve a couple of different, somewhat harder molar conversions. Gram to gram types and molecular types. These are 3 steps or even more. This is screencast 9.4. Grab a calculator and let's begin. Okay, I see 3 problems here. A gram to gram one, another gram to gram one, and a microgram to molecule one. Anytime we have a gram to gram conversion, it's 3 steps. And the general procedure is to start with what you're given, write out those 3 steps, and then convert so you end up with the given product. The first problem says if you're burning 100 grams of butane and you got plenty of oxygen, how many grams of carbon dioxide will it produce? Okay, we start with the 100 grams of butane and recognize that since it's gram to gram, it's 3 steps. The excess oxygen tells us we don't have to worry about the oxygen because there's plenty. It plays no role in the mathematical part of the solution. So here's what we're going to do. I'll say it first and then I will show it to you next. I'm going to go from grams of butane to moles of butane so that grams of butane cancels. And then we need to go from moles of butane to moles of carbon dioxide because it's not a 1-to-1 ratio, it's a 2 to 8, which is a 1-to-4 ratio. And then we don't need the moles of carbon dioxide, we need the grams of carbon dioxide, so we'll convert from moles of carbon dioxide to grams of carbon dioxide. Here we go. 58 grams of butane is a mole. How do I know that? 4 times 12 is 48, plus the 10 is 58. Those are the molar masses for each atom. Why did I set it up like that? So that grams of butane cancels. And mole of butane, well, 2 moles of butane makes 8 moles of carbon dioxide. Yes, I could have done 1 and 4. We now are at the moles of carbon dioxide stage, but we need the grams of carbon dioxide. No problem, 44 grams of carbon dioxide is a mole, 12 plus 32. This gives us an answer of 303 grams of carbon dioxide. It's always a good idea to cancel your units like this to make sure that the only units left standing are the ones that you need. Here's another one. I hope for this one that you don't just copy it down, but rather you pause the video, solve it completely yourself, and see if you get the same answer I did. We're burning a pound of butane, 453 grams. How many grams of water will it make? Similar but not identical to the problem above. Go ahead and do it. Okay, here's what you should have got. Start with what you're given, write down your 3 steps, and convert. 58 grams of butane is still a mole. In this case, 2 moles of butane produces 10 moles of water. Check it out there, there. I could have done 1 and 5. And anytime you have a mole of water, it's 18 grams. Multiply it through after canceling your units. Did you get 703 grams of water? I hope you did. Last problem. If a microgram of butane is set on fire, my God, that's not much. How many molecules of carbon dioxide will produce? Well, molecules seems to always be a large number. I do expect a large number from this. Start with what you're given and try to figure out how many steps it is. It's going to be, I think, 4 steps. This was shown to you, so if you need this, go ahead and use it. We'll go from the micrograms to grams, or you could just start directly recognizing that there's 1,000,000 micrograms in a gram. That's be a memorization. Moles of butane, then to moles of carbon dioxide. Looks like it's a 2 to 8, 4 times as many. And then we don't have to go to grams of carbon dioxide. We can go directly from moles to molecules. These are the particular particles of carbon dioxide we're interested in, and a mole is always 6 times 10 to the 23rd. Plenty of oxygen, so ignore it. And here we are. A microgram of butane is the same as 1/1,000,000th of a gram, since 1,000,000 grams, or 10 to the 6th micrograms, I should say, of butane. There are 1,000,000 micrograms in a gram. Fine. Anytime you have 58 grams of butane, it's a mole. And 2 moles of butane forms 8 moles of carbon dioxide. But we need to go to molecules. A mole of carbon dioxide will contain 6 times 10 to the 23rd molecules of carbon dioxide because that's how many a mole is. Multiply all of that through with your scientific calculator and you should get, after canceling your units, 4.1 times 10 to the 16th grams of carbon dioxide. If you got that right, congratulations. That's the hardest one in this series. And this is Screencast 9.4.